welcome everyone. In today's video, we will integrate a vision model from NVIDIA NIM in our application. In the previous video, we learned how to integrate the text model from NVIDIA NIM into our application. We will build the user interface using the Chainlit for our application. We will build a chatbot that will accept the image and query about the image. Answer the query about the image and mark the image according to the query. To build this chatbot, we will use the vision model from NVIDIA NIM. Let's get started. Open your browser and type NVIDIA NIM. Go to the website. Here you will see many open source models. Click on Try Now. In the Models section, you will see models for reasoning, visual design, retrieval, speech, and biology. Here you can explore all the models. Click on Reasoning. In Reasoning, you will find the text models and vision models. So we are going to try out the Kosmos 2 vision model from Microsoft. Click on the Kosmos 2 model. Here you will find the user interface to try the model and the code which you can integrate into your application. To integrate the Kosmos 2 model into your application, you need this code and the NVIDIA API key, which you can generate from the Get API key. Click on the Get API key. To get the API key, you need to log in. You can log in by your personal email, and you will get the free 1,000 credits for API calls. If you have a corporate email, you can log in with that, and you will get the free 5,000 credits for API calls. After login, now click on Get API Key. Click on the Generate Key and your NVIDIA API key has been created. Go to the VS Code and create a .env file. Paste your NVIDIA API key in the .env file. Now, let's create the virtual environment by following this command. Our virtual environment has been created. Now we will activate our virtual environment using the name of the virtual environment, /scripts/activate command. After activating the virtual environment, we will create the requirements txt file to write down the required libraries. Now run this command to install all the required libraries. All the required libraries have been installed. Create a new file to write the code. Go back to the NVIDIA website and copy the Python code. Paste the code in the file. Now, provide your NVIDIA API key for the authorization. Give the path of your image. First, I will move my image to this project directory. Modify the question in the payload. Let's understand this code. This code is designed to interact with NVIDIA's AI API to analyze an image and return information about it. This code imports two libraries: requests library for HTTP requests and base64 library for encoding the image. This code open an image file, read its contents, and encode it in base64. Then, define headers including the authorization token and the content type. Next, create the payload with the message including the base64 encoded image. And use the requests library to send a post request to the API endpoint. At last, it prints the JSON response from the API. Now run the file. You can see the response in JSON format. In response content, it gives the information about the image. To integrate that in the Chainlit application for user interface, let's create a new file name UI.py. First, let's start with importing the necessary modules. Import requests. Import base64. Import OS. Import matplotlib.pyplot as PLT. Import matplotlib.patches as patches. From PL, import image. Import Chainlit as CL. We begin by importing the necessary libraries. These include requests for making HTTP requests, base64 for encoding, OS for interacting with the operating system, matplotlib for plotting, PL for image processing, and Chainlit for handling messages. Now, create a function to resize the image. Def resize_image, image_path, max_size, sadface 800, 800. Image equals imaged. Open image_path. If imaged, size 0, max_size 0, or imaged, size 1, max_size 1. Image.thumbnail, max_size, image.lengths. Resized_path equals resized_ plus os.pathed, base name, image_path. Image.save, resized_path. Return resized_path. Return image_path. This function resizes an image if it's larger than the specified maximum size. It opens the image, checks its dimensions, and resizes it if necessary. The resized image is saved and its path is returned. Next, we will create a function to call the NVIDIA API. Def get _ bounding _ boxes, image _ path, API _ key, message _ content. Invoke _ URL equals https://aid api nvidia.com/v1/vlm/microsoft/cosmos-2. We define the function get _ bounding _ boxes, which will send the image to the NVIDIA API. We also specify the API endpoint. Now, we will open the image file and encode it in base64 format. We also check that the encoded image size is within the allowed limit. With open image _ path, RB as F. Image _ B64 equals base64. B64 encode, F read, decode. Assert len, image _ B64, 180_000. To upload larger images, use the Assets API, see docs. Next, we will set up the headers for our HTTP request, including the API key for authorization. Headers equals authorization, F, bearer, API _ key, accept, application/JSON. Now, we will prepare the payload for the API request. This will include the message content with the embedded base64 image. Payload equals messages, role user, content, F, message _ content, img src equals data, image/png, base64, image _ B64 /, max _ tokens 1024, temperature 0.20, top _ p 0.20. Next, we will send the HTTP post request and convert the response to a JSON format. Response equals request post, invoke _ URL, headers equals headers, JSON equals payload. Response _ data equals response, JSON. Now, we will parse the response to extract bounding boxes and the response text. We will also handle the case where no entities are detected. Boxes equals response _ text equals if choices in response _ data. Response _ text equals response _ data, choices 0, message, content. Entities equals response _ data, choices 0, message, entities. For entity and entities, boxes, extend, entity boxes. Finally, we will return the bounding boxes and the response text. Return boxes, response _ text. Now, let's visualize the detected bounding boxes on the image. Now, we will define a function plot _ image _ with _ boxes to visualize the detected bounding boxes on the image. Def plot _ image _ with _ boxes, image _ path, boxes. Image equals imaged, open image _ path. Fig, ax equals plt.subplots 1, ax.imshow image. Here, we open the image and set up a plot using matplotlib. Next, we will define a list of colors to use for different bounding boxes. Colors equals red, blue, green, yellow, purple, cyan. Now, we will loop through each bounding box, calculate its position and size relative to the image dimensions, and draw a rectangle on the image. For box, color and zip, boxes, colors. X equals box, 0, asterisk image.width. White equals box, 1, asterisk image.height. Width equals box, 2, box, 0, asterisk image.width. Height equals box, 3 box, 1, asterisk image.height. Rect equals patches, rectangle, X, Y, width, height, line width equals 2, edge color equals color, face color equals none, ax.add _ patch, rect. Next, we will turn off the axis and return the figure. plt.axis off. Return fig. Finally, let's handle messages in Chainlit. Next, we will define an asynchronous function to handle incoming messages. If no file is attached, we send an error message. At CL on underscore message. Async def on underscore message, message, CL message. If not message elements. Await CL message, content equals no file attached dot send. Return. Now, we will filter the attached files to process only images. If no image is found, we send an error message. Images equals file for file in message elements if image in file.mime. If not images. Await CL message, content equals no image file attached.send. Return. Next, we will get the path of the first image, resize it, and retrieve the NVIDIA API key from environment variables. Image underscore path equals images 0.path. Resized underscore image underscore path equals resize underscore image underscore path. API underscore key equals OS, GitInv, NVIDIA underscore API underscore key. Now, we will call the function to get bounding boxes and plot them on the image. Boxes response underscore text equals get underscore bounding underscore boxes, resized underscore image underscore path, API underscore key, message content. Fig equals plot underscore image underscore with underscore boxes, resized underscore image underscore path, boxes. Finally, we will create a message with the response text and the plot and send it back. Elements equals CL pyplot, name equals plot, figure equals fig, display equals inline. Await CL message. Content equals F, response underscore text. Elements equals elements. Dot send. That's it. Now run the file using Chainlit runui.py. Now it automatically opens this page, which you can see running in port number 8000 localhost. Now I will attach the image and ask the query what is in this image. Here you can see the response. In the response, it tells about the images and also marks the image with colorful rectangles. Let's test it on different image. You can see the response. In today's video, we integrated the vision model from NVIDIA NIM in our application and created the chatbot using the vision model and Chainlit for the user interface of the chatbot. I hope you found this video helpful. Thanks for watching, and let's meet again in the next video.